Hi guys, I'm Kevin. What I'm gonna talk today is the very fundamental of aircon engineering using refrigerant and how does all this refrigerant works. Okay, the to begin with is that all gas can be liquefied. So we've seen liquefied oxygen, nitrogen, liquefied petroleum gas. Any gas can be compressed and liquefied. So why do you want to liquefy gas? For very obvious purpose is that a compressed liquefied gas holds as much as 600 to 1,000 times its actual volume. So that allows you to pack your liquefied oxygen to climb Mount Everest or go for deep sea diving. So, but the interesting thing is that when engineers begin to compress and liquefy gas, they witness a very interesting concept. Is that, take for instance, if I have this huge amount of gas in a cylinder, imagine this is a cylinder, okay, and I compress it to like 1,000 times its actual volume. So like this length compressed until here. So or maybe for simplicity we say about this, okay, this gas becomes superheated, very hot. And what happens is that if I use a fan and I start to fan on it and get rid of the extra heat, the gas actually begins to liquefy. So this is how you liquefy a gas. You need something to compress it and you need something to get rid of the heat. Very simple, two things: a compressor and a fan. So, and this is how your condenser looks like, right? You have a compressor. So the compressor basically compress the gas, and then you have this very big condensing coil because the gas is inside the copper pipe. The aluminum fin is to increase the surface area. So that is a radiator, and you have a fan to get rid of the extra heat. So getting rid of the extra heat is very important. So if you can't get rid of the extra heat, the gas do not fully compress, liquefy into a gas form. So now we are going to talk about some of the misunderstanding about reading gas pressure. So okay, the concept is like this: if I have this amount of gas, I compress until I produce this amount of liquefied gas. So this is roughly about 120 ml of liquid gas. As long as, if this is R22 gas, as long as there is a pressure of about 150 psi pressing down on this gas, this liquid gas will not vaporize. It's like it's trying to vaporize, but there's something pressing down, so it remains as a liquid. If this is the R410 gas, it's a different kind of gas. In fact, it takes a higher pressure. I think it's about 250 psi. A lot harder to keep this as a liquid form. So this is like a is like a potential energy. It's like a spring loading mechanism that is ready to jump out and turn back into a liquid form. So R410 being a high pressure gas, in fact, has got more energy. But on the contrary, it means that a compressor have to compress like crazy to keep it down. So there's a balance, So which is more efficient? But generally, 410 has got more energy pack. It's a high pressure gas. So what happens now is that if I lift up my this pressure, suddenly this gas will vaporize. And when it vaporizes, depending on how fast it vaporizes, just like letting a dog out of a leash, how fast it goes. You want to put it under control. You don't want it to go too fast. So this is the inner working of the compressor, how you calibrate the expansion valve. Last time they used capillary tubes. So that's a pressure control. So as I lift this up, the liquid gas vaporize. So imagine if I lift up until here, okay, I increase the space. As I increase the pressure drop from, okay, let's keep it simple. Let's talk about R410 gas, because that is the gas we're using now. At 250, okay, I press it down, it's a liquid. I lift it up to 150. What happens is that some of the gas, not all, some of the gas will begin to vaporize and turn back into a gas. But imagine this is a sealed chamber. So the gas that evaporates, right, now actually it begins to expand. And as it begins to expand, 150 slowly comes to 160, 170, 180, and finally the pressure will still be equalized at 250 psi. So meaning to say, no matter what time I measure this, it will always try to equalize at 250 psi. So I lift it up further, more gas will vaporize. So what that changes is the amount of the ratio of the liquid gas versus the amount of gas, but it will always maintain about 250 psi. So if you start to experience a pressure drop, so when technicians measure the pressure of the gas, actually they put a meter, actually measure the pressure of the gas at this chamber. So if I'm supposed to measure 250 psi and I start to experience a pressure drop, what it means is that, but it's not so simple because the compressor is turning. That I will cover later. If you start to see a pressure drop, say 125 psi, half the pressure. So some of the technicians say that, oh yeah, you have lost half of your gas. That's inaccurate. That's very wrong. In fact, you have lost almost all of the gas. Because whatever that you lost half of it. You will vaporize and try to balance this. When you start to see a pressure drop of about 50%, chances are you're left with so little liquefied gas that whatever that is vaporizing, it's not enough to fill up the gap and cause a pressure equilibrium. So okay, that is aircon engineering. So the concept, if I can summarize, is that at the compressor, you compress it, blows away the hot air. So very important is that put your condenser at a place that is well ventilated. Some people put the condenser at the yard area, especially for condo. Now HDB also got yard area. And then they've got too much stuff. They got boxes, they got swimming floats, everything. They start to chuck and chuck behind the condenser somehow. So that's gonna block the airflow. So don't do that. If you start doing that, your aircon is gonna run very inefficiently, sucks out a lot of energy bill, cause a lot of overheating, damage the fan motor, etc. Don't do that. Keep that area well ventilated. The condenser is meant to be an outdoor unit. Is IP rated. It's weatherproof, stormproof. It's not afraid of rain. It's built to be in the open. And it's good to be out in the rain because when the condensing coil behind picks up dust, when it rains, it washes away the dust. And it just keeps going. It's maintenance free. But if you put it inside a balcony, you put it in the service yard, and if it's so well sheltered, the rain doesn't come inside, then if your place is dusty, the back of the condenser can get clogged up. and that's when you need to flush water. Water will do, just splash. So make sure that it's properly cleaned up, don't go and block it up. So with the condenser that is well positioned, it compress and it produce the right amount of liquid gas. So in an inverter system, you can produce so-called refrigerant on demand, because you can change the speed of the compressor. You can compress more, and so as a result, the inverter system has got very huge liquid receiver. So that's just to store the excess liquefied gas, because the compressor can produce like 8,000 BTU, double it, 16,000 BTU, 24,000 BTU worth of refrigerant. So, and this liquid gas is actually sent through a pipeline in the copper pipe. At what pressure? In fact, when you compress it, you hold it at 250 psi. The gas comes out this way. And after the expansion valve, the pressure actually drops to, because one side is high pressure, the other side is a returning low pressure. So it's like lifting already. So after the expansion valve, the pressure will drop to, in fact, very low. It's not 150 psi, it's way lower, but it's the gas that evaporates and starts filling up the gas. So you will start to experience like 120, 150 psi when the gas starts filling up, because it's a closed system. So as long as the compressor is turning, one side of the pressure goes up to 250, the other side may start to drop to about 120, 130 psi, 180. Depends on how many aircon you have turned it on. So this gas, this liquefied gas, it depends on where you want to put your expansion device, the EEV or capillary tube, whatever. There are some aircon model that puts the we call the EEV the metering device. So basically it just means that it creates a diameter so small that when the compressor is pressing on one side, the pressure goes up, and after it passes this, the pressure drops, and this is where you create the pressure difference for the gas to evaporate. Why you want the pressure difference is that when you lift up the pressure and the pressure drops, the liquid gas turns into gas, and the reverse happens, it becomes cold. You lift it up too fast, it becomes too cold, it turns into ice. So that's why when your gas pressure is low, it's a very interesting concept. You say you not enough gas and then ice starts to form. It's because not enough gas, there's too much space for the gas to evaporate. It evaporates too fast, and as a result, it flashes too fast and ice starts to form. But the volume is very little. So usually the first coil begins to ice up, and the rest of the coil is just not cold at all. So you want to have a controlled amount where it flash between like 3 to 5 degrees. Last time actually higher, because they don't want the room to be too dry, and to fill up like 3/4 of the coil. But with inverter technology, with a computer system, you can even have a full coil, so less material, a lot of things that goes into it. So that we will cover later, or maybe shortly after this. So this gas, but nowadays they put the metering device or the linear expansion valve at the condenser, not at the fan coil, because when the gas flash, actually there's noise. So if you put at the fan coil, you will hear like hissing sounds. Some find it too unbearable. But there's beauty in that. If you put it at the expansion coil, meaning to say the copper pipe that comes from the condenser into the fan coil, this whole pipe is still under the high pressure state, and this pipe is hot. So that's why last time they call this a hot pipe. So the pipe that goes to the fan coil is hot pipe. After the fan coil comes back is cold pipe. Efficiency is better. pros and cons. The advantage is efficiency. Disadvantage is that the pipe is under high pressure. So if there's a leak, then it's going to run out of gas very quickly. Because these are third-party pipe. The condenser is built in the manufacturer factory. So the material that is procured by the manufacturer is under tight control. The quality of the copper and everything, and the system is all blazed, welded, under very strong good quality control. So for this condenser to leak, the chance is low. Then after that, you ship the condenser, and installer buy their own copper pipe, join by flare joint, runs it, corner, they have to bend it. They don't bend it properly, they kink it, then open it up again, it may fracture the pipe. So this part that is after the condenser is out of control of the manufacturer. So if you want a high pressure pipe on this, you expose yourself to greater risk. So they decided that they want to put the expansion device at the condenser area. So meaning to say, any point after the condenser is the gas is already a low pressure environment, ready to flash. The moment it come in contact with outside temperature change, this gas will evaporate. So that's why from the condenser all the way to your room aircon, they're gonna keep this copper pipe very much sheltered. So it's not supposed to come in contact with any temperature change. It's not gonna come in contact with any moisture. So they put this insulation material, like wearing a jacket, so that you don't come in contact with external heat. So this copper pipe, they have this insulation material circulating, they slave it in about roughly about 1.5 meters, and then they join another piece. By right, you should put glue, then join these two pieces together, tape it around. Different materials have different insulation property, so installers will upsell you actually a better material. So better and better materials are coming into the market. There are insulation material that actually have like a canvas material on the outside. So in my opinion, that is very good material, because sometimes when you start to pull the insulation material at tight corners, you tear the soft sponge, and as a result, air goes in, heat exchange, copper pipe internally becomes cold and condensed. So no wonder sometimes HDB, you see all those copper pipe that is running in the casing, you got all those thin black color mark, because the insulation is bad. But of course, it's when it comes to installation, sometimes it's that, and most of the time it's because contractors needs to do it very quickly. So the insulation material is, the standard material is 2" by 3". After the copper pipe with an insulation is roughly 1 inch. So in 2" to 3", you can pack maximum of 1, 2, 3, 4, 5, 6. Am I right? 3 sets of pipe. But the problem here is that, not forgetting, is that 3 sets of copper pipe means that you are serving a system 3 aircon, because 1 forward pipe, 1 returning pipe. So in this spacing of 2" by 3", you pack nicely 3 sets of pipe, and then you have 3 electrical cable. That's the problem. So how you gonna make space for these 3 electrical cable? And sometimes you run the water pipe inside the casing. So that's why installation, sometimes you a few aircon shares 1 water pipe, because of space constraint. So if each aircon runs its own water pipe, you don't even have enough space. So it results in squeezing and squashing. So the electric cable that runs inside, actually between 2 insulation material, will actually cause a snatch. This insulation material is roughly maybe about probably about 5 cm thick, 5 mm thick, yeah, or at most about 8 mm. So this material being so thick, your electrical cable is roughly about 10 mm. Squash in between two sponge, each takes half of it. You find your insulation material is left with like 1 mm thick. And throughout the whole line, got all this electrical cable, got 3 pieces. Some corner where your pipe needs to turn. So it's taking up space. So especially you see the condensation on your casing, it always occurs somewhere around the bend. And not forgetting is that installers wants to do things fast, otherwise it's not profitable. So they open up the casing, they chuck the material, cable all anyhow run. So things are overlapping one another. It's not like straighten or nicely packed, So that's not the case. So a lot of overlapping things like that. So insulation materials are squashed. And this place that is with very thin insulation material, coupled with a copper pipe that is already at a low pressure environment, ready to flash, it's gonna absorb the heat from the environment. Your casing actually begins to condense. But that's not only it, because not forgetting is that manufacturers are pushing the technology and causing the gas to flash at a much lower temperature. So it's going to greatly increase that probability. So once this thing comes inside your fan coil, so instead of insulating it, now they begin to expose it. Wow, so suddenly now you have this fan coil with those aluminum fins to greatly increase the surface area. The gas suddenly is like, oh, holiday. Wow, they evaporate like crazy. Then this is how the coil becomes cold. So the fan is not blowing on the cold fan coil, don't get it wrong. They call it a blower, but in reality it's a sucker. It sucks the cold air and then blows it out. So the fan coil, okay, imagine this is the fan coil. Okay, if I have a fan and I blow, after the coil I get cold air. Okay, but this is not the case. This is a fan. Okay, it turns and it sucks the cold air in. Okay, and then blows it out this way. So this material, the fan rotor, is always in contact with cold air. So despite selection of material is always plastic, it can become so cold and begins to condense too. Old fan coil design is like that. Okay, the fan coil is very tall. That's why those very old aircon is like huge, humongous. To make the aircon more efficient, this fan coil now is actually an A shape, like this. It sort of like wraps around the blower. So when this coil which is wrapped around it, and to make the aircon even more efficient, okay, this is the copper pipe, and you have this aluminum fins to increase the surface area of the fan coil. You want to increase your efficiency and at the meantime lower your shipping costs, manufacturing costs, resulted in a fan coil with this wrap around coil design, and it posed a huge problem. So with this wrap around fan coil design, the fins are built tighter. Why? Because they want to make the material thinner. Last time so thick, more aluminum. You want to use less aluminum, thinner, but you want more surface area, half, build it tighter. When you build it tighter, what else can you do? You punch the material. So the air actually goes through the fin like this. So inside the fan coil is very, very efficient and tight. Coupled with a fan coil that is very cold, you're gonna get enormous condensation. In Singapore, our relative humidity roughly 70 to 80%, and in a prolonged rainy season, and especially if you stay near to nature park, don't be surprised to get 100% humidity level. The amount of water that the aircon can suck up from one given room in 1 to 2 hours can easily be 5 to 10 liters. That's the amount of water that is forming at your fan coil. It's just ridiculous. So we are running into a lot of aircon problem, mold issues, etc. And our lifestyle needs to change because the technology makes it very difficult for you to have a bacteria mold proof environment. There are methods, so we have to understand how it works. Your lifestyle needs to change because technology has changed, working not in your favor, unfortunately. It's working in a favor of going for 3 tick aircon and 4 tick aircon. 4 tick sells better than 3 tick. 5 tick sells better than 4 ticks. The engineering is going that direction. It's not going the other way around. Your aircon is going to be more problematic one day after another. It can't be helped, and it won't reverse. So what makes matter worse is that now your coil is going to condense like crazy. So after you turn on your aircon, this fan coil is all wet. And in worst scenario, if the fan coil is not properly designed, it can be so wet